All right, so I think this is recording. Let's take a look here at problem number 4. We have two rational expressions. We're asked to divide the two rational expressions, write it as a single rational expression in lowest terms, and to also state any restrictions that we have. And that's where we have to be really careful with division, because there's going to be at 2 points during our solution that we have to stop and think about restrictions. And right now, looking at those denominators, it's not in factored form, and I really can't see much and determine much about restrictions when my denominators are not in factored form. So that's where I'm going to start. Let's look at this first fraction, and let's look at this denominator. Let's come off to the side. We've got 7a cubed, and I'm going to write it as 7a squared times a. I know that the a squared times a is a cubed because 2 plus 1 is 3. I'm going to rewrite 56a squared as 7a squared times 8. And now it should be obvious that 7a squared is common to both terms. I can factor out that 7a squared, and what I have left in the first term is just a, and what I have left in the second term is 8. All right, let's continue. Let's look over here at the next denominator. It's a trinomial, so I can't factor it in the same way that I did with the greatest common factor of this binomial, but we do have a technique that we refer to as the X method that should work fine in this case. I like to put my X off to the side rather than putting it directly over my middle term, specifically when I have negative signs. When I draw the lines through there in the past, sometimes I've thought that I've accidentally changed my subtraction to an addition, so I draw it off to the side. My middle term is 7a. My first term times my last term is negative 8a squared. So now a trial and error begins where we're trying to look for two expressions that when multiplied together give us the top value, but when added give us the bottom. So 8a times negative 1a I think will do the trick, because when you multiply them together you get this top expression. When you add them together you get the bottom. Now if this leading coefficient were different than 1, we would have to come down below here or somewhere, make a table, and continue factoring this using a table. But we have a shortcut. When the leading coefficient is 1, we can just come over and we can use the 8 and negative 1 and say that we have a plus 8 times a minus 1. All right, so let's come back over to our original problem. Our first fraction, the numerator was 7a squared. We just left that alone. The 7a cubed plus 56a squared, I factored that up here, and that factors to 7a squared times a plus 8. I'm dividing my second fraction here. My denominator was a trinomial, and I used the X method and factored it to a plus 8 times a minus 1. So I'm ready now to look at both of these denominators that are in factored form and recognize what some of my restrictions are going to be. When I look over here, I see a single factor of a, so I know that a cannot be 0, because if it were, 0 squared is 0, 7 times 0 is 0, 0 times this a plus 8 is 0, 0 times anything is 0. I'm going to get a 0 in the denominator, and I need to avoid that. Well, look at this binomial. Negative 8 plus 8 would give me a 0 as well, so I have to restrict and say negative 8, or excuse me, that a cannot equal negative 8. When I look at the denominator in my second fraction, I've already listed negative 8 as being a restriction, so I don't have to list it again. When I look at a minus 1, I know that 1 minus 1 gives me a 0, and I have to add 1 to my restriction. All right, so let's look now and see what we have. Well, one thing that we have that I noticed right away is that 7a squared divided by 7a squared is 1. So I can write this as times 1. So this first fraction reduces. I have 1 over a plus 8. I'm going to change the division to multiplication, and I'm going to take the reciprocal of the divisor. I'm going to flip this fraction. So I have a plus 8 and a minus 1 in the numerator. And when that flips, I have a new denominator. So anytime I have a new denominator, I have to pause and think, did that introduce any additional restrictions? Well, in this case, it doesn't, because this 2, now be careful, my 2's and my a's look a lot alike. This 2 is not a variable, and that 2 is not going to mysteriously change to a 0. I don't have to worry about division by 0 when I flip this fraction. All right, so let's look and see, are there any further? Well, let's write these two fractions as a single fraction by multiplying the two numerators together and the denominators together. So it's easy to multiply by 1. We have a plus 8 and a minus 1. 1 is the multiplicative identity. When you multiply by 1, you get the identical thing back. Now, in the denominator, I have this binomial times 2. I'm going to write the 2 out in front, and then a plus 8, because I can multiply in any order, and that just feels more like standard form. It feels more comfortable for me when I do that. You don't necessarily have to write the multiplication in that order. I see that I have a factor of a plus 8 divided by a plus 8. That's just 1. Now, of course, I haven't written my restriction yet. My restriction comes along for the ride for each step. And we're ready to state our final answer because we have a minus 1 divided by 2, and that's a single rational expression in lowest terms, and from the beginning it would never reduce to that if we didn't have these restrictions. If a were allowed to be a 0, there's no way it would reduce to this. If a were allowed to be negative 8, it would be undefined. If it was allowed to be positive 1, we'd have trouble. All right, so here's our final answer. Don't be afraid to ask questions. Hope this helps, and I'll talk to you later. Bye.